So far we've mainly been doing a lot of looking at a lot of the terminology for statistics and looking at the different types of graphs and the different types of ways to display the information. Now we're actually going to get into a little bit more of the, how about we're in the wrong chapter? So today we're going to do a lot of looking at finding the measures of center. Throughout this chapter we're going to start looking at calculating out how much variance there is between different values and what those things mean. So just kind of giving you a quick review of what we've done. So chapter 1, we distinguished between population and sample. If you're figuring out a calculation about the population, then that's called a parameter. If you're finding a calculation about the sample, then that's called a statistic. Then we also looked at the good sampling methods. Your goal is to get a simple random sample. And so it needs to be collected in an appropriate way to be able to be usable. And that is going to be a criteria that we have on almost all of the data that we try to evaluate and look at, is that we started off with a good, simple, random sample. Because if you started off with a bad sample, everything else is just junk. Chapter 2, we talked about the frequency distribution, how it summarizes the data, and we looked at how graphs are designed to help us understand the data. Well, chapter 3 then, we're going to look at some important statistics. We're going to talk about the mean, the median, the standard deviation, and the variance. And we're going to try to figure out what those mean and how we can interpret those pieces of information. We're going to look at the difference between descriptive and inferential statistics. In descriptive statistics, that's going to be in this chapter. We'll learn to summarize or describe numerically the important characteristics of a known set of data. So you're describing the data that you've got. Inferential statistics we'll do later on in the semester is going to use the sample data we have to make inferences or generalizations about a population. So if we knew the difference between if I found a sample of NCMC students and I found that the mean age was 20, then that mean age of 20 is describing that set of data. If I was to try to take the group of those students and try to infer what the mean age of all NCMC students are, then that would be that inferential statistics of saying that we think that the ages are between, the average age, the mean age is between such and such, between 19 and a half and 25 years old, or whatever we have as our range of data values. So that's what you're looking at with inferential statistics, so we'll get into later. Questions so far about where we're heading? All right, looking for our measures of center then. Measures of centers are the value at the center or middle of a data set. There's more than one way to find that center and to describe that center. The one you hear the most often in general terminology is called average. In statistics and in mathematics, we call it the mean, or the arithmetic mean. That is the measure of the center obtained by adding the values and dividing the total by the number of values. So your mean is the one that you guys are already usually pretty familiar with finding when we're talking about describing that center value. The notation that we'll use, and you're going to see this notation a lot throughout the semester, the sigma denotes the sum of all those values. So when we're talking about the fact that you're going to add all the numbers together, sigma is used to say it's the sum of all those data values. X is the variable that we usually use to represent the individual data values. N represents the number of data values in the sample. So when we're looking at doing this is saying, and capital N represents the number of data values in the population. So each of these are going to be variables that you're going to see throughout the entire semester. So this is adding all the values together. This is telling me that's my variable that represents the original data. This tells me how many are in the sample. This tells me how many were in the population that we're working with. So if I am trying to find the sample mean is going to be denoted by X bar. That means the mean of all the samples. We've already said to find the mean, you add all the numbers together and divide by how many there are. So the sample mean is the sum of all my X's, adding all my data values divided by the number in my sample. So this is working with a sample. This is working with your population. Instead, we have to designate whether we're talking about the sample or a population, whether it's a statistic or whether it's a parameter. So mu is your mean for your population. So it's the Greek letter mu, where it's going to have a similar style of way of finding it. You still add all the numbers together and divide by how many there are, but now it's finding the population mean. You're adding all the data values in the population, and you're dividing by the total number in the population. And so we're using the capital N to describe the population total versus the lowercase n to designate that it was the sample total. Calculate and then will be the same, but you're still going to have to recognize whether you're talking about a population mean or a sample mean. And so keeping track of whether you're finding x bar or whether you're finding mu is going to be important. And it's going to be used throughout the semester. I want you guys to come up and write down how many siblings you have. So just bring your markers with you and just make a list for me of how many siblings you have. So now that we have our, and this would just be even if we were talking about our class, since we're missing people, then this would be a sample of our number of siblings for a statistics student, or if you wanted to just consider you guys as a random sample of NCMC students, talking about the number of siblings. I want you guys to find the mean of your sibling data. So as you're finding the mean, first thing you're going to do is find the total. So if we are adding the 0, 1, 2, 3, 2, 1, 3, you should get, and this will be an x bar because it is a sample. So it's the sum of our x's divided by the number in our sample. So what was the sum? Divided by the number in our sample, which was, so as you divide, we are going to get 1.714. We'll talk in a second about the rounding. This one's going to need to be rounded to 1 decimal, and so we would round that to 1.7 siblings. So the mean number of siblings would be the 1.7 siblings for our sample of our class. The median. The median is the middle value. First thing you have to do is put things in order. So it does not matter if you put it in order from least to greatest or from greatest to least, but you have to put it in order first. The abbreviation that we use for the median is x tilde. It's got the little squiggly line above it. You're not going to see that again, so that's not one you need to memorize, but just being aware that it does have its own little designation we can use. But if we were trying to find the median, actually for our data, we put things in order, we would have, actually, do I have a page for that next? No. Oh, I guess I do have directions on how to find the median first. First thing to do to find the median, you have to put it in order. So if we were to put ours in order, we would have the 0, 1, 1, 2, 2, 3, 3. Okay? If your number of data values is odd, then the median is the number located in the exact middle of our list. So because we have an odd number, then you're going to look at 7 divided by 2 would be 3.5, so you're going to use that fourth number. And so in this case, that would be our median. The median, that middle value, is 2 siblings. If, on the other hand, if the number of data values is even, the median is found by computing the mean of the 2 middle numbers. Let's say, just to make things nice and balanced, we had another 0 over here. to where we tried to find the median at that point. Now that you have 8 values, there's not a middle number. The middle number would be whatever's between the 1 and the 2. So to find the mean between those, you would just add them and divide by 2, so we're going to end up with 1.5. Questions on calculating the median? Hopefully it's one that you're familiar with already. Median, one of the ways to help you remember that the median is that middle value. If you're driving down the interstate, you've got that grass in the middle is called the median, and that's that middle part between the other 2 roads. And so your median is still that middle value. Questions there? If we looked at finding the mode, mode is the one that happens the most often. It's the one that happens with the greatest frequency. Data sets can have more than one or no mode, depending upon the situation. So mode is the one that happens that most often. How many modes do we have? We have 3 modes. Then we would have the 1, the 2, and the 3 would all be modes. If we went with adding the extra 0 in there, then that would say we had no modes because all of them occurred with the same frequency. But your mode is that one that's happening the most often. If we threw another 3 in there so that we have one of the numbers that happens more often, then the 3 would be the mode. Even though the 2 and the 1 happened more than once, the 3 would have happened the most often if I threw an extra 3 in there. So ours would be an example of something that is multimodal, that there's more than 2 data values that occur with the same greatest frequency. Bimodal happens quite often that you have 2 data values that occur with the same greatest frequency. So bi, like bicycle, has 2 wheels. Bimodal has 2 modes. And then there's times that you have no mode, that no data value is repeated, or they're all repeated the same amount of times, in our case, which is pretty rare. Questions there? So finding the mode of our sibling data. The mode is the only measure of center that can be used at the nominal level of measurement. What does that mean? What did it mean by the nominal level of measurement? Nominal would be name. So this is when you're talking about things that are only types of names. If I was talking about the different colors of shirts, then we would have the names of the different colors. The only thing I can do if I was dealing with colors is figure out which one happened the most often. Because you really can't put any other, you can't average the different kinds of colors to make any sense out of that, to find what that median or the mean, either one, would look like. And so the only type of way we could describe the type of center would be the one that happened the most often, if you're talking about things that are names. If you're dealing with political parties, whether they are Republican, Democrat, Libertarian, Independent, you can just look at the ones that occur the most often. You cannot figure it out any other way to talk about the center on those. So nominal means in name only. So the mode's the only type of center we can talk about when we do that. The mid-range is hardly ever used, but the mid-range is the value midway between the maximum and minimum values in the original data set. So for our example, the mid-range would be that value between our maximum of 3 and our minimum of 0. Well, if you're talking about the thing that's the midway between 3 and 0, you would add 3 and 0 and divide by 2, and we would get that 1.5 is that center of that. Now, the reason we hardly ever use mid-range is it is extremely, outliers make a huge difference in it. It's easily affected by those outliers. Because let's say in my class, we had one person who had 9 siblings. So 9 siblings is obviously an outlier in comparison to all the rest of these that we were having. Well, if you're having that with having the 9 siblings, then that has really affected where you're looking at having that center, because the mid-range between 9 and 0, we would take that 9 plus 0 and divide by 2, and so it would tell me the middle is at 4.5. So it's really, really affected by those outliers. Now, a lot of these other ones are also, and we'll look at how much that outlier, I think here in just a second, we'll talk about the outlier. So for finding the mid-range, you take the maximum value plus the minimum value and divide it by 2. And do that. Now, pay attention to the difference between the median and the mid-range. They're both describing the center. The median takes just those 2 numbers that are in the middle and finds the middle between those 2 values. Versus the mid-range is taking the 2 extremes and finding the middle between the 2 extremes. And so there's a big difference between what you're looking for as you do those. So when you're looking for the median, you figure out where the center is, and if you have an odd number, then you're just using that middle number. But if you have an even number, you're finding the center between those 2. But the mid-range is looking at the 2 extremes, so all you care about is what was the most and what was the least in that group, and finding the middle between those 2 extremes. The round-off rule. Round-off rule is one of those things that I will be kind of particular about, because if we're looking at the round-off rule, the rule is you carry 1 more decimal place than is present in the original set of values. We need to keep some sort of consistency, that if you're talking about the number of siblings that we have, we'll round that to 1 more decimal place, so we round it to 1 decimal. If you are carrying the amount of money that people were having, and you are counting it to the nearest penny, then when we go to find the median or the mean and those type of things, we'll round it to 1 more decimal, so you'll round it to the half penny. But if you're looking at measuring money and you've only been measuring the money to the closest 10,000 of a dollar, so you round them to $10,000 because you're working with these huge things, huge numbers. Well, if you're working with rounding everything to $10,000, the nearest $10,000, and you go and find the median, or let's go and find the mean. So you're adding them all up, dividing by how many there are. Well, it's probably going to not come out friendly, and it'll probably come out to decimals. And if you rounded that answer to 2 decimal places, then somebody that looks at that, and you're giving an answer that, that the mean amount of money that was spent on advertising at NCMC was, and we come up with some, over the last 10 years, I'm just totally guessing at some numbers here. If you're rounding it to something like this, then it sounds like you were pretty precise with all of your measurements. And it sounds like you were actually going out to the nearest at least dollar when you were finding all these things out. Well, if you were just going to the nearest $10,000, then what we really would need to round this to would be $111,000. Because that tells you, that last rounded part tells you how accurate those original measurements were. And so you've got to be careful with what you do with those rounding rules. So I will be particular as you're looking at these. So when you're looking at having original data and you are calculating out the mean, the median, the mode, the mid-range, any of those things, you're going to take it to 1 more decimal than what your data already had. Questions? If we have that we're trying to find the mean from a frequency distribution. So somebody has already said, all right, let's go with our groceries. How many people spent between $0 and $9.99? How many people spent between $10 and $19.99? How many people spent in each of those different things? Well, you've lost your original data. You don't know how many people came in and spent, $4.40. You just know how many people spent between or spent less than $10. Well, if you're trying to take that frequency distribution and figure out, well, what is the center of that? Then the way we calculate that out, that it would be the mean of a sample. You're going to take the sum, where you multiply the frequencies times the data value, and divide that by the sum of the frequencies, where x is the middle Oops, I don't have it written. Thought I did. X is that midpoint of that frequency distribution. Where X is the midpoint of each class. I'm not seeing that I have the example talking about the outliers. I guess that must be in a future thing. So let's look at number 97 or number 30 on page 97. I want to find the mean of the data summarized in the given frequency distribution. Also compare the computed means to the actual means obtained by using the original list of data values, which came from the different exercises we've already done, which I guess on number 30 is going to be 76.3 beats per minute. So that's what it would be if you actually took the original data. So if we look at the pulse rates of females, we had 12 values that fell between 60 and 69. We had 14 between 70 and 79. The problem is we don't know when we look at having 12 in that range of 60 to 69 what those original values were. So we're going to have to take that frequency times the midpoint. Well, what was the midpoint of between 60 and 60.9? Okay. So we'll have to take the 12 times the 64.5 plus, so this is taking the sum of the frequencies times x and divided by the total number in our sample. It's going to give me my sample mean. We'll take the 14 times what? So I'm going to let you have a minute to go ahead and do that. Let's go ahead and do the rest of it. You're welcome. All of this should be divided by what? 40? Was it 30/70? Is that right? Okay. I'll give you guys a moment to finish getting to that. Questions getting to there? That's frustrating. It is 11 times 84.5, isn't it? So that's the reason why you're having problems. So you're doing the right thing. I'm not going to make you go back and retype it all in. Because you are doing the right thing. Uh-huh. Are you getting it, Trevor? Okay, the problem? One of the problems. I left out some numbers as part of the problem. There was a ... in there. You need to use your table to get the rest of it. Whatever page I'm on. Page 97. Yeah, that throws you off. So we're using that data, so I just sort of skipped the middle. The other thing to be careful of, when you put it all like this, all this did was divide 40 into this last thing, and then it added all the rest of that to it, which is the reason why you got such a big number. So it's one of those you'll have to either put a bunch of parentheses in there, or easier just hit enter and then divide by 40. Okay, so once you did this, we're getting the 76.75. Is that the appropriate place to round to? Okay, what was the original data? Okay, the original data was pulse rates of females. How accurately would we have measured the pulse rates of females? Do you measure a half a heartbeat? No, it's either one heartbeat or it's not a heartbeat. There's no in between. So we were measuring to the nearest heartbeat. If we're measuring to the nearest heartbeat, then what do we need to measure to round this to? Okay, we need to round this to one more decimal, so we're going to round this to 76.8. And this would be 76.8 beats per minute. Now, how does that compare to the original? If we went back to the original data that we had in previous chapters, it is 76.3 beats per minute. It's pretty close. If we went back to the original data and we get a heart rate of 76.3 beats per minute, then we're getting 76.8 beats per minute. We're off by less than a heartbeat, which is pretty accurate as you're looking at doing these. So it's going to be most of the time relatively close. Sometimes it can get pretty skewed, especially if you have a lot of your values are in some of those extremes as you're doing them. So it's not always going to be quite as accurate, but when you don't have the original data, it's the best we've got. Questions doing that one? Okay, looking at some of the measures of center. So this chart kind of organizes these things. This is, I don't remember, is this in your guys' book or is this the one I put on the website? Can't remember. I don't think this one's in the book. I think this I've got on Blackboard if you really wanted to look at it closer. So your different types of measures of center. We have the mean. To find the mean, you're going to find the sum of all the values, then divide by the total number of values you have. Couple things. The mean is sensitive to extreme values. Sample means tend to vary less than other measures of center. So your sample means finding it from one sample compared to, like one sample of NCMC students compared to another sample of NCMC students, it's probably not going to have a lot of change from one to the other. The thing is, it is sensitive to those outliers. So if we went back to our students that I threw in having one person that had 9 siblings, how did that change my mean? So find the mean of this new one where I have the 9 in there. So when we didn't have the 9 in there, our mean before, I don't remember what it was. Before we had the 1.7, now when I add that 9 in there, we should be getting a mean of 2.6. So just having that one outlier really pulled the mean its direction, because we're now rounding up to 3 versus rounding up to having 2 siblings. And so it has really changed what that mean is going to look like by just having that outlier in there. Okay, another type of measure of center we had is the median. With the median, that's where you're going to sort the data first. If it's an odd number of values, the median is that number in the very middle. If it's an even number of values, then you're going to add those two middle numbers and divide by 2. An advantage to the median is it's often a good choice if there are some extreme values. The median is not pulled very far away from where that center really is. When we had these things in order, we had the 0, 1, 1, 2, 2, 3, 3, and then if I put the 9 in there, well, when we didn't have the 9 in there, the 2 was the very center. When I add the 9, now I've got 8 values. Well, the middle 2, in this case, are both going to be 2s, so the mean of the 2 2s is still 2. My median did not change by having that extreme of having 9 siblings. Even when we put another one of the 0, it didn't pull it very far away from where it was. It stayed pretty close. So the median does not get pulled as far away when you have those outliers in there. And so if you're really looking at something that you've got some extremes, the median might be a good way to express the center. A lot of times when you talk about income, they usually don't talk about the mean income, they talk about the median income. So if you're talking about the income of engineers, they would talk about the median income of engineers, because you've got some people that are new and not making a lot. Then you've got those engineers that are for really large firms and are making buku dollars. Well, what you really want to know is, what's that middle value? What is the number in the middle? Because those people making buku dollars are really going to pull that up a lot and have an effect on it. The mode. Mode is a value that occurs the most frequently. The mode is good for data at the nominal level of measurement. So the mode tells you the one that happens the most often, especially if you're dealing with things that are categories. Categories, you can only deal with the mode. Saying what happens the most frequently. The mid-range is hardly ever used because it is very sensitive to those outliers, but it takes the maximum value and the minimum value and just finds what's in the middle between those two. Range, and we'll talk about range next time, is just saying what's that difference between the maximum and minimum. So the mid-range is saying the middle of what that range is, the middle of those extremes. And so if you were talking about engineers, and you were looking at those people that didn't make a lot compared to the one that made the buku dollars, the mid-range is not going to be a very good indication of how much the normal engineer would make, because that one with buku dollars has really skewed things a lot, again, as you're doing things. Questions there? When we talk about data being skewed then, most of the time we talk about data, well, hopefully we have data that's a nice normal distribution. Well, if I have that normal distribution, that's great. But that doesn't always happen. Sometimes it is skewed to the left. which is also called negatively skewed, which has a longer left tail, which will have the mean and the median are on the left of the mode. So when you're looking at it, it has a long tail on the left, and then you have your maximum occur. So you've got the extremes that there's somebody that's way down there. So if you were talking about incomes, there's somebody that doesn't make much of anything compared to where most people are falling, but that you don't have very many people that are making a whole lot. This might be a good one of teachers. You don't have very many that are making a whole lot, but you've got a lot that are down here not making a whole lot when they're in some of those smaller districts. And so having that one being skewed to the left or negatively skewed. Hopefully, our class grades will be negatively skewed. That'll hardly have anybody down here making bad grades and everybody up here making good grades. That's our goal for statistics. Skewed to the right, which is also called positively skewed, have a longer right tail, and the mean and median are to the right of the mode. So when you're having it being skewed to the right, we're going to have a few that are out here making a lot of the large amount, but then most of them are going to be down here on this other end. And so this might be your engineers that are having somebody that's making buku dollars, that the fact that there's somebody out there that's making way more than the rest is really going to keep that tail going out there a long ways. Well, if we look at the graphs, again, if it's nice and symmetric, if it's perfectly symmetric, the mean, median, and mode are all the exact same number. Mode is the one that happens the most often. If it's perfectly symmetric, then as you drop off a little bit here, you're dropping off a little bit here, and those values are just canceling each other out. And so your mean, when you add all the values up and divide by how many there are, ends up being in the middle. The median is looking for that middle value. If it's perfectly symmetric, then it's folding over on top of itself, and so that middle value is also in the middle, the same as your mode. That highest point is always your mode. If it is negatively skewed, then your mode is still that highest point, but by having somebody that's down here, so if we were talking about, again, percents in our class, then most of the people are up here making A's and B's, but if you've got somebody with a really low percent, then that low percent is dragging the mean and the median to the left with it. And so that's why it's negatively skewed, is it's pulling it in the negative direction, pulling the mean and the median in that negative direction. On the other hand, if you have it positively skewed or skewed to the right, then it's pulling that mean and the median. So if we had somebody that's making a lot of extra money, then they're pulling that mean and the median in their direction. The mode, the one that's still the most often, is going to be over here. Now, you can't guarantee if you look at data and you see that the mean and the median are larger than the mode, that it's obviously got to be negatively skewed. But it is a time to say, I need to look at the distribution of that data and see what does it look like as you go through this. Questions here? Okay, before we do that one, I want you guys to think about, and this is because of my rounding rules, I want you to think about this situation. If you called the bank and you remember when you get off the phone that your balance was around $125. And so then you're going to go through and you're going to write some checks. Well, let me just write checks because I'm running out of space. So if we just have some checks, and we have checks for $50, $26.81, $12.24, $15.36, and then we know we make a deposit of $21.15. So we have all this going on. My question is, can I write a check for $40? You got that one? Okay. I want you guys to write on your boards whether you think you can write a check for $40. This was an answer. No, it's that. Okay, as you do all of this, what are we getting? Okay, so we got $41.74. So can I write a check for $40? Okay. Are we guaranteed to have $1.74 left? Why not? I didn't know my exact original balance. What if my original balance was really $122.80? I remembered it's around $125. So when I get to the end, I no longer have $41. I didn't write down how much I have. Instead of having $41.74, I'm going to have 39 something. And I just bounced a check. I know the overdraft has gotten larger. I don't remember what it was now. What was that? The bank will be really happy with that concept. So as you look at doing this, having that approximation made a big difference in our answer. Saying that it's around $125 really made a big difference in what we've got. When we're looking at this, since it's around $125, we've rounded to that 125. That's telling me anything between, it's got a pretty wide range in there of what we would round up to that 125. Now, we might have had extra. If I remembered to round the 125, I might have actually had $127 in there. But the fact that I didn't really remember real well how much money I had doesn't mean you want to go down to that nearest $1.74 when you're going to write your checks. So be careful with what you're doing as you're doing these things. That's the reason why I'm very particular about your rounding rules, because having the fact that we're rounding to something tells me we can't be any more accurate than what we already started with. This was rounding it. It wasn't even rounding it really to the nearest dollar. It was to that nearest half. Nearest $5 was what we were rounding it to. So as we were getting to the end, we could only round it maybe to the nearest dollar when we were doing things, or less. It's a hard one to kind of describe what we'd be doing. But be careful with your rounding on those. All right, this is your guys' homework for the weekend. I do have a couple things for you. I've got the extended problems to give you, along with the review for the test. I know the test isn't for a little while, but it's just if you wanted to start looking over some of the review kind of things. And I've got a Super Bowl worksheet, and I'm trying to figure out if I want to give this to you today. I think I'll wait and give this to you on Monday. It is not that you have to watch the Super Bowl. No, it's got previous data that we're going to use to find some information and ask some questions.